What if I told you the most dangerous substance in the universe is also inside your own body right now? That the same force that powers the sun and can level cities is used every single day to save lives in hospitals? Most people hear the word radioactive and picture green glowing ooze, nuclear wastelands, and guys in hazmat suits. And yeah, that's not totally wrong, but it's like only knowing about sharks from the movie Jaws. The reality is so much weirder, more complex, and frankly, more amazing. We're going to unravel the mystery of every important radioactive element, from the ones that date ancient skeletons to the man-made terrors that haunt our history. So what is radioactivity? Why is it so powerful? And how did its discovery change humanity forever? Stick around because the answers will fundamentally change how you see the world. All right, let's set the scene. It's the late 1890s. People are riding horse-drawn carriages. Electricity is still a wild new thing, and science is like exploding with discoveries. In a cluttered Parisian lab, a brilliant scientist named Marie Curie is messing around with a heavy, unassuming rock. This rock is called pitchblende, and it contains uranium. Scientists already knew uranium did something weird. It fogged up photographic plates, even in complete darkness, like it was haunted by some invisible ghost. That's your first clue. That ghost was energy, an invisible, powerful energy pouring out of the very heart of matter. This was radioactivity, the universe revealing a secret power source it had kept hidden since the dawn of time. But here's where it gets crazy. Marie Curie realized something was off. The pitchblende was way more radioactive than the amount of uranium in it could explain. It was like hearing a symphony orchestra, but only seeing a guy with a triangle. There had to be something else in there. What was it? So she and her husband Pierre begin this insane, grueling process of breaking down tons of pitchblende. It's physically demanding, dangerous work. And after years of effort, they find not one, but two new elements hiding in the rock. The first she names polonium, after her homeland, Poland. The second was a monster. It was 1,000,000 times more radioactive than uranium. It glowed in the dark with this eerie, beautiful blue light. She called it radium. And people went nuts for it. They had no idea of the danger. Companies put radium in everything: toothpaste for a brighter smile, face creams for a youthful glow, even chocolate and water that promised to cure all your ailments. You could buy radium-laced underwear. I'm not kidding. They thought this magical, glowing stuff was the key to eternal health. Of course, they were tragically wrong. The very thing that made it glow was also tearing their bodies apart on a cellular level. But how? What is actually happening inside a radioactive atom? Think of an atom's nucleus like a ridiculously overpacked suitcase. Some suitcases are packed perfectly, they're stable, they can sit there for billions of years, but others, they're bulging at the seams, ready to pop. These are the unstable radioactive atoms. To relieve the pressure, the nucleus just throws stuff out. It's called radioactive decay. Sometimes it throws out a big, clunky particle called an alpha particle. It's like tossing a bowling ball. It's powerful up close, but you can stop it with a piece of paper. Other times it spits out a teeny, fast-moving beta particle. This is more like a bullet. It goes farther, and you'd need something like aluminum foil to stop it. And then there's the big one, gamma rays. This isn't a particle at all. It's a blast of pure energy. It's a ghost that can pass through walls. You need thick lead or concrete to stop it. So alpha, beta, gamma, that's the stuff being thrown out. That's the radiation. The discovery of this process was one of the most important moments in human history. It was the key to understanding the atom, and it unlocked a power that would lead to humanity's greatest achievements and its most terrifying nightmares. The secret was out of the box, but what would we do with it? Hey, just jumping in for a second. We make these videos because we believe understanding the world from history to science is incredibly important. Our goal is to make complex topics simple and super engaging. If you're enjoying this journey into the heart of the atom and you want more deep dives like this, do us a huge favor and hit that subscribe button. It's free and it helps us create more content just like this. Thanks, you guys are awesome. Now, back to the story. Okay, so now we know what radioactivity is. It's atoms falling apart, but not all radioactive elements are created equal. Some are gentle background characters in the story of our planet. Some are medical superheroes, and some are straight-up supervillains. Let's meet the lineup. First up, the naturals. You're probably picturing a lump of glowing green uranium, right? And yeah, uranium is the OG, the heavyweight champion of natural radioactive elements. It's been in the Earth's crust since the planet formed. But the radioactive element you interact with most often? It's probably potassium-40. Yeah, that's right. It's in bananas. It's in potatoes. It's in you. A tiny fraction of all the potassium in the world is radioactive. So yes, you are technically slightly radioactive. It's completely harmless, but it's a great reminder that radioactivity is a natural part of our world. And it's super useful. Take carbon-14. It's created in the atmosphere and absorbed by all living things. When an animal or plant dies, it stops taking in new carbon-14, and the stuff already in its body starts to decay at a perfectly predictable rate. So by measuring how much is left, archaeologists can date ancient bones, wood, and artifacts. Carbon-14 is our time machine to the past. But what happens when this natural radioactivity gets concentrated? In some places, uranium in the ground decays into radium, which then decays into radon, a radioactive gas. It can seep into basements and build up to dangerous levels. It's a silent, invisible threat. So nature gives us tools, but it also lays traps. The game changed, though, when we stopped just finding radioactive elements and started making them. Enter plutonium. This element basically doesn't exist in nature. We had to build it, atom by atom, in a machine called a nuclear reactor. Why? Because while it's hard to make a bomb out of natural uranium, easier is the wrong word, but it's possible with plutonium. It's what's known as a fissile material. This is where radioactivity gets a whole lot scarier. Forget just throwing out little particles. A fissile atom like plutonium does something else. If you hit its nucleus with a stray neutron particle, it doesn't just decay, it shatters. It splits into two smaller atoms, releasing a ton of energy and, crucially, 2 or 3 more neutrons. That's called a nuclear fission. Now, what do you think happens if those new neutrons hit other plutonium atoms? They split, releasing more neutrons, which hit more atoms, which split, releasing more neutrons. It's a chain reaction. And if you let it run away from you, it happens millions of times in a fraction of a second. The result is an explosion of unimaginable power. The atomic bomb. Humanity had learned to tap the power of the stars and turn it into a weapon. But is that the whole story? Is man-made radiation only for destruction? Not even close. Let's talk about technetium-99. Like plutonium, it's artificial. It was the very first element we ever created in a lab. And its superpower? It gives off gamma rays, and it has a very short half-life, meaning it decays and becomes non-radioactive very quickly, in just a few hours. This makes it the perfect medical spy. Doctors can attach it to a molecule that your body sends to a specific place, like your heart or your brain. They inject it into you, and for a short time, you emit a tiny amount of harmless radiation. A special camera can see it, and doctors get this incredible real-time map of what's happening inside your body. It's a cornerstone of modern diagnostic medicine. The same nuclear science that gave us the bomb gave us a way to see inside ourselves without a knife. But with great power comes great potential for disaster. The most famous nuclear accident in history wasn't a nuclear bomb. It was a power plant, Chernobyl. When the reactor at Chernobyl exploded, it wasn't a nuclear fission bomb. It was a steam explosion that blew the roof off and set the core on fire. For 10 days, it belched a cloud of radioactive particles into the atmosphere. The most dangerous of these weren't uranium or plutonium. They were the byproducts of fission, elements like cesium-137 and strontium-90. Here's why they're so terrifying. Your body is smart, but it can be fooled. Chemically, cesium looks a lot like potassium, which your muscles need. Strontium looks a lot like calcium, which your bones are made of. So if you breathe in or eat these radioactive elements, your body doesn't reject them. It welcomes them in. It literally builds them into the fabric of your body, into your muscles, into your bones, where they sit for decades, irradiating you from the inside out. That's the insidious horror of nuclear fallout. It's the ultimate Trojan horse, an invisible enemy you unknowingly invite into your own cells. This is the dark side of the atomic age, a power so immense that when we lose control of it, the consequences can poison the earth for centuries. So are we stuck? Is this a devil's bargain we can't escape? Or is there another way? So we've seen it all. The natural, the man-made, the lifesaver, the city destroyer. It feels like we're stuck between a rock and a hard place. We need energy, but the most powerful source we've ever found comes with these insane risks. The waste from uranium and plutonium reactors stays dangerously radioactive for hundreds of thousands of years. What if I told you there's another radioactive element that could change all of that? Meet thorium. Thorium is another naturally occurring radioactive element, even more abundant than uranium. And it's a potential game changer. You can't make a bomb out of it easily. A thorium reactor is theoretically meltdown proof, and the waste it produces, it's still radioactive, but for a few hundred years, not a few 100,000. It's like a choice between a campfire that's dangerous for an evening versus a chemical fire that makes the ground toxic for generations. So why aren't we using it everywhere? The short answer is history. Back in the Cold War, the big nuclear powers were focused on the uranium-plutonium cycle because it gave them a convenient byproduct, weapons-grade plutonium. Thorium didn't. So all the research, money, and development went down the uranium path, and thorium was mostly forgotten. We chose the path that gave us bombs. But the idea is making a comeback. As we face a climate crisis and an ever-growing need for clean energy, scientists are looking at thorium again, wondering if this forgotten element could be the key to our future. And that really brings us to the heart of the matter. Radioactivity itself isn't good or evil. It just is. It's a fundamental force of the universe. An unstable atom trying to find peace is the same process whether it's happening in a banana, a cancer treatment machine, the sun, or a nuclear warhead. The story of these elements isn't really about the atoms themselves. It's about us. It's about a species that unlocked a cosmic secret and suddenly had to figure out what to do with godlike power. We learned it could give us limitless energy, or it could be the end of everything. It could show us the inner workings of our own bodies, or poison us from within. From Marie Curie's glowing vials to the terrifying specter of Chernobyl, our journey with the atom has been one of brilliance, hubris, terror, and hope. We opened Pandora's box, and now we have to live with what came out. The question is no longer what radioactivity is, but what we will choose to do with it. What do you think? Is nuclear power using elements like thorium the answer to our energy crisis, or are the risks just too great? Let me know your thoughts down in the comments. I read as many as I can. And if you enjoyed this trip through the periodic table, please give this video a like. And if you haven't already, hit subscribe and ring that bell so you don't miss our next deep dive. Thanks for watching. Stay curious.